In this demonstration, I'd like to give you a quick overview of UTS Neutron, IPC Global's new next-generation dynamic testing and analysis software. Firstly, UTS Neutron is run from one single application, meaning that instead of needing all the separate test applications that we had with the original UTS software, seen here at the top of the screen, all the individual test applications are now templates within the UTS Neutron platform. So if we launch UTS Neutron, you'll see the introduction pop up. You can select from a choice of languages. Additional languages will be added in the future. Plus there's a custom language configurator, so you can set it up to run the test in any language. So we'll select English and click OK. Here you can see the overall structure of the software platform. On the left side we have a toolbar menu. We can open an existing test application template, review previous test data, create a new test. Use the new test wizard where it's easy for anybody to create their own test, following an easy step-by-step process. This is shown in a separate video demonstration. User management, where you can create new users and assign the level of access they're allowed. For example, a QC operator, a laboratory manager, administrator or head engineer. I'll sign in as IPC administrator. Enter the password and log in. Now you'll see the test folders that are set up on this PC. 4-point bend, asphalt creep, dynamic modulus, general, indirect tensile modulus, and test wizard. You can create new folders or edit the folders as required for your laboratory. Test templates will be saved in these folders. So we'll open the dynamic modulus folder and then AASHTO T342, which for those of you familiar with the UTS software is the equivalent of UTS 23. Double click to select this template. It will display the title image, the test description. It also shows the user access levels that can be set and changed by a manager or administrator. Click here to load the template. Click OK and apply. So the template loads. I'll just maximize the screen. This first tab in the test interface section, where you can enter test general information, test setup, frequency sweep table, specimen information. If we now move to the test data page, this is where when a test is running, you'll be able to see results in the table and the graphs plotted here. If we go into the test control tab, this is where the building blocks of the UTS Neutron test templates are generated. We can configure I/O modules, test information. So if you have the developer license and the knowledge, you'll also have access to Python scripting, where you can enter your own software code to program the machine to do anything you like. This is shown in more detail in another demonstration video. The first stage for creating a test would be to set up the acquisition to tell the system how we're going to capture the data. Then the loading blocks to tell the system how we're going to perform the specimen loading. And at the end of the test we can also generate a report for presenting the test results. So now we'll go back to the test interface tab, system setup. Again, for people familiar with UTS, this is where we allocate the test transducers. In the current template we have an actuator position transducer, load cells, 3 displacement transducers and a temperature probe. New to UTS Neutron software are the smart plug and play transducers. With these, all the calibration and identification is loaded into the transducer's ILC inline signal transducer. So all the information is automatically uploaded into the IMAX2 controller. So if I unplug one, all the information disappears. And if I plug it back in, all the information is automatically sent to UTS Neutron. This new feature will eliminate operator errors because with these, it's not necessary to allocate a calibration record to a transducer. Now we'll close this and open up the levels screen. This has new, clean and richer information. The virtual pendant used for setting up the testing machine can be embedded at the top, where you can control each control axis. This system is controlling an EMS servo-electric actuator in a new IPC Global Asphalt Cube modular dynamic testing machine. Here we can turn the system off or on. The machine limits can be displayed on the right hand side. These can be set to restrict movement, to protect transducers or jigs from overload. The level screen is really useful for setting up tests or monitoring transducers until you're ready to run the test. So we'll close the level screen and import old UTS data file into the new software. So I'll import UTS1 data. First, locate the files on your system. You can import a binary file with all the test setting, parameters and results, or a CSV file. And for this example, we'll load a CSV file. Here you can see the results table, populated with each frequency sweep showing the dynamic modulus, phase angle, and all the quality parameters. We can also view each of the various frequencies to look at the wave shapes or the stress strains and so on.